Okay, I wanted to finish this last page in the notes. Okay, so what we want to do here is define what a polynomial is like. And polynomials are defined and continuous for all of the numbers in the domain. Okay, any number we would choose would be continuous. We already talked about it being a kind of a smooth graph, right? And it doesn't stop. It doesn't have any holes, any asymptotes, anything like that. So what it does have is it has smooth, right in here, smooth, rounded turns. Fill that blank with rounded. Smooth, rounded turns. Okay. Things that it does not have. It does not have any breaks in the graph. Okay. It does not have any holes in the graph. It does not have any gaps in the graph. If you are writing, please write down the word gaps. I can't fit it in here. It doesn't have any asymptotes. Okay. It doesn't have any sharp corners. Okay. Or pointy turns. No pointy turns like it did up here, right? This is not a polynomial. It has to have smooth turns. Okay. Now, when the leading coefficient is positive, remember we defined our polynomials, the first term is an x to the nth power, whatever it is, right? So here's our leading term. If we write it in order, this would be our leading term. A sub n is our leading coefficient. This is our leading coefficient. Leading coefficient, right? So if that number in front of our leading term, right, is positive and n is odd, so now the exponent, right, the exponent is odd and the term is positive, then at least we know on the ends it's going down on the left, and on the end on the right it's going up. We don't know for sure what's happening in between, but we know the end behavior has to look like this. So I'm going to draw it like this so we know. Okay? The end behavior on the left is down, the end behavior on the right is up. If n is even, so this one you can just think about like y equals 2x, right? Because y equals 2x looks like this. The end behavior is down on the left and up on the right. This is 2x to the first. But when n is even, think about a parabola, right? A positive parabola looks like that. So the end behavior for a parabola or anything with an even power is up on the left and up on the right, as long as this is positive, right? So you have two choices. It's either going to go down on the left and up on the right, or down up on the left and up on the right, depending on whether the power or the exponent is positive. Sorry, whether the exponent is odd or even, I should say. Okay. If the leading term is negative, then it does the opposite. So look at this graph over here, right? Look at the graph when n is odd and it's positive. Look at this box here. Look at that graph. And it's going to be the opposite of that, right? It's going to go up on the left and down on the right. So think of a curve, think of negative 2x. Negative 2x graph looks like this, right? It's up on the left and down on the right. We don't know what's going on in between. It's going to depend on what the power actually is. But if the power is odd, look over here. The power is odd and the leading coefficient is negative. It looks like this. If it's negative and even, then it's down on both sides. Okay, so it's just like a parabola flipped over. Think of negative x squared. It's flipped upside down, right? So anytime you have an even power, an even degree, right? The degree is even. The power of the exponent is even, but it's negative. So it's got to be negative, like negative x squared. It's going to be pointing down on both sides. So you see that covers all four possibilities. Okay. Okay, on this next problem, I'm going to do number 1, and then I'm going to leave it for you to do number 2. Okay. Number 1, we want to find all the zeros. We want to determine end behavior, domain, range, blah 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 blah. Okay. So first thing we want to do is find the zeros. So let's factor out, right? Let's set this equal to 0 and factor out the x. So we got x times x squared plus 3. And remember I said to change this to x squared, please? So now when you factor out x out of x squared, you get x plus 2 equals 0. And this factors fully as x plus 2 times x plus 1. Now we have three possible zeros over here. We have x equals 0. If we solve for this one, we're going to get x equals negative 2. We're going to get x equals negative 1. You may need to write that step out. X plus 2 equals 0, then subtract 2. X plus 1 equals 0, and subtract 1. Both sides. Okay. So here's our zeros, right? That's our A. Okay. B, determine end behavior. How are we going to find end behavior? We're looking right up here. End behavior, right? We're looking up here. Which situation is this? This is an odd power. So we're looking here, odd power, what I'm circling in red, odd power, odd degree, but it's a positive coefficient. The positive coefficient is this section right here. So look, it's where these two meet. It looks like this. So we know it's down on the left and up on the right. Now, remember how we write end behavior. We're going to do the limit of the function f of x. See if you can write it on your own. As x approaches positive infinity. So on the right side of the graph, what's happening? It's going up to positive infinity. What about the limit on the left? What about the limit of the function as we go to negative infinity? Well, it's going down to negative infinity. Okay, that was an easy one. So that's your end behavior. That's part B. That's your answers for part B. C, what is the domain? We've talked about this. Forget number 2 for a second. C, what is the domain on number 1? It is all real numbers or negative infinity to infinity. Remember, all polynomials have all real numbers for the domain. What is the range? Now look at this graph, right? Look at this graph. This thing goes down forever and up forever. So what is the range? The range is also all real numbers, okay? Or negative infinity to infinity. There's no y value that's not covered by this graph. E, give a rough sketch. Then F, check your rough sketch by using decimal graphic calculator. Find the extrema, okay? So, part E, we're going to do a rough sketch. Now, how do we do a rough sketch? Well, we know on the edges it's going down forever on the left and up forever on the right. And it's crossing, right? It has to cross the x-axis at these values, okay? So at x equals 0, at x equals negative 2, and at x equals 1, it has to cross the graph. And on the edges, it's going down on the left. Now look, this is the last time it crosses the x-axis. So if it goes down on the left, it has to shoot down like that. On the right side, this is the last 0 on the right, and we know it has to shoot up on the right. So there we go. Now, how am I going to fill in the rest of this graph? Well, it must go up a little bit and down a little bit between those points. Otherwise, it wouldn't connect like this. So that is a rough sketch. Okay. G, that is F and G and H. I want to see if you can use Desmos or use your graphing calculator to see if this is accurate. Was this an accurate graph? What do you think? Okay. On G, I want you to find the extrema with the calculator. And then state what type of extrema you have, okay? Is it relative min, relative max, absolute min, absolute max, etc., okay? Do that. And why don't you just do that, as well as watch the video and fill in the blanks that we just filled in. And we'll leave number 2 for class.